Number 6. Okay, so I'm trying to find the measure of angle L, the measure of angle M, but inside them it has these strange looking, those are called expressions. They're not equations because it doesn't have an equal right there. So that's just an expression. So I have to use what I know about triangles and their relationships. So here's what I know. All three of them add up to be 180 degrees. So I could get the supplement of this one. But I also know that for the exterior angle theorem, if I add these two remote interior angles, I can set them equal to the exterior angle of 161. That would allow me to solve it for the variable z. Okay, so for number 6, I'm going to start with this 18z plus 3, and I'm going to add 5z minus 3 was in this remote interior angle. Okay, so I'm getting the sum of these two, and I'm setting it equal to the one that is outside. Okay, so now this is a very lengthy equation, but I'm going to make it shorter because I'm going to find the things that are alike. So on the left side of the equal sign, I see that I have 18z in front, and then I have a positive 5z right here. So if I put them all together, that's 18, 19, 20, 21, 22, 23z. Whoa, that's not a z. Okay. The other thing that I notice is that I've got a constant right here, 3 positives. And then back here I've got 3 negatives. So whenever you have 3 positives and 3 negatives, well, you're just going to cancel out that 0 pair. So there's nothing else to bring down except for this other side, 161. Y'all know this is multiplying, so we have to divide both sides of the equation by 23. 23 divided by 23 is 1. So I'm just going to write my 1z. I don't know that. 161 divided by 23 is 7. Good thing I got a pretty number. Okay. I'll go back to my note page. Wherever there was a z, I'm going to substitute a 7. So by angle L, write 18 times 7 plus 3. By angle M, it's going to be 5 times 7 minus 3. Okay, so for angle L, 18 times 7 plus 3 is 129 degrees. So whenever I look at angle L, it is obtuse. So the degrees should be between 90 and 180. So that works. Angle M is acute. 7 times 5 is 35. So 35 minus 3 is 32 degrees. So it's acute. That's less than 90. That works. Now I need to find where this one is. LKM. LKM. LKM is this tiny little acute angle, and it is supplementary with this obtuse angle because they're side by side, they're adjacent, and they're forming a straight line. So since a straight line is 180 degrees, and I can already see 161 degrees, I will subtract 180 minus 161. That tells me that it's 19 degrees, and it was really little, so 19 works. My last step is to check to see that all of these interior angles of this triangle add up to be 180, and it checks. Okay. Last one, describe the relationships among the measures of the angles of a triangle. Okay, so there's this thing called the triangle sum theorem. You need to know that the triangle sum theorem means the angles inside the triangle have a sum of 180 degrees. You have to know that. The angles of a triangle have a sum of 180 degrees. The other thing that you need to know about the relationships, about the measures of angles of triangles, is the exterior angle theorem. The exterior angle theorem says the exterior angle of a triangle is the sum of the remote interior angles. The exterior angle theorem says the exterior angle of a triangle, so angle that's outside the triangle, is the sum, so I add the remote interior angles. So I just travel away from it to be remote. No, it's not right beside it. You travel away from the exterior angle and you add up those two measures.